So we do many things which are not yet adopted by the water utilities, and everyone knows that water utility is sort of conservative in the adoption, and now is a big push because of the recent what we see around, even increasingly digitalization. But with increased digitalization, there is a risk for like a cybersecurity risk.
Welcome to the Urbanista, where we discuss the water management challenges of Nordic cities. From safe drinking water distribution and stormwater collection to building sustainable urban living environments. Here is your host, Delphine Vassallo.
Hey, welcome to the Urbanista, where we discuss the challenges about water management in cities. I'm your host, Delphine Vassallo, and we are here in the World Water Congress in Copenhagen, Denmark, where there has been a lot of topics discussed today. And one of the key things that is on everybody's mouth is technology. How the technology that the water utilities are using is improving, what is coming. And one of the key things that we have seen repeatedly is the technology applied to monitoring the water quality. That has one of the big things, big discussion topics here today. And for that, I have a very special guest here that will tell us, well, how the research, how the technologies has been moving at this point. So, who are you and what do you do?
Hello everyone, I'm Patryk Wójtowicz. I am research manager in Savonia University of Applied Sciences in Kuopio, Finland. We are also leaders of the Kuopio Water Cluster. We are here in the World Water Congress in Copenhagen, also within the Finnish pavilion. It happened that we are also your sort of neighbors, and that's why I got this opportunity, which I would like to thank you to get invited and just tell a little bit about what we do in Kuopio. There's also, I will then tell you, there's a kind of a link between us and Uponor, which I will tell you about later. But let's go back maybe to my introduction. I'm leading the Smart Water Group in the Faculty of Environmental Engineering, Kuopio, Finland again. I hope that you can check on Google Maps where Kuopio actually is.
I hope that north.
Yeah, we are in the
east.
Yeah, you land in Helsinki, and Kuopio is in the midway to Lapland if you want to see the official place of Santa Claus.
So that's basically in the way to see Santa Claus.
Exactly. And then in Kuopio we have a water lab, which is specializing, of course, as the name implies, on water technologies, but not only the clean water, but also industrial water. So we also into wastewater. Equally, especially the mining and pulp and paper. We have actually two specializations. One is smart water, which happened to be, I'm here as a leader of this specialization, and the second one is the zero emission industry. So anything regarding the water intensive industries that are using resources, we try to make sure that we are staying on top of the technologies that allow us to reduce the emissions, or towards, of course, totally zero emission industries that are still can use the resources in the future, despite of the regulatory changes and all these really harsh requirements that are coming in terms of, for example, of nitrogen or phosphorus emissions from mining and COD for pulp and paper. So we want to respond proactively, ensure that these new technologies are available for companies to be commercialized and then used in the real world. So these are two specializations that we have in Kuopio, and Water Laboratory is, of course, full of opportunities for the SMEs. And we are also leaders of the Kuopio Water Cluster, and in which we are cooperating very closely with the companies.
Because what is the Kuopio Water Cluster exactly? Kuopio, that depends from you, or is that a separate entity, or who is there?
It is. We are leading the Kuopio. We formed the Kuopio Water Cluster together with other founding members. And we have, because everything started from the idea that if you want to be serious in your research and you want to make sure that academia and companies get closer together, you have to be always having these bearings towards the actual product. So we have in the cluster we have a public university, University of Eastern Finland. They are part of the cluster, and also other public institutions like GTK, Geological Survey of Finland, and other relevant in each sector. We combine that together. So it gives us the power of combined more than 150 experts available for the companies. But I'm going back to these companies. From the beginning, we would like to make sure the cluster role is to make sure that those ideas that are starting in academia could be converted to the real products at the end. You have to make really harsh decisions at the low TRL levels, these technological readiness levels, the low ones. So we allow them to make sure that only the good ideas that are promising the product will went through. So we allow making the proof of concepts at the beginning, and then the pilot those at the site, or make the development in the laboratory. So that's why we need the Kuopio Water Cluster. With currently more than 65 members, we can involve them at the very early stage. So we stay neutral because we are still a university, Savonia University of Applied Sciences, and all these other actors, their role is not to make business, it's to support the business and commercialization. That's why we need the cluster in order to operate effectively and make the innovation, take the innovation to the market.
Because one of the topics that we have been hearing also here during the World Water Congress is this whole ecosystem of the water management is very, very complex. There are many stakeholders involved, of course, government, academia, manufacturers, water utilities, and it seems that we are not communicating that well, or we are not communicated at all. So this, well, not exercise, this reality that you already have, like connecting the university, the research with actual companies, it's because you started. You started with that, and it was your initiative to reach out to the companies.
Yes.
And then how they were, what was that journey? I mean, really knocking the door and, look, can we collaborate? Can we test your product? Can we give you, because apparently we as an industry, we are kind of very reluctant to talk to each other. I'm not sure why, but what was your journey to connect with these companies, to bring them into the cluster?
Yeah, with all this, because clusters are, of course, known. This is a known. At the beginning, I think they were called like ecosystems when you have some kind of a partnerships being built. In our case, we were capitalizing on more than 20 years of history in Kuopio, and those founding members were cooperating on loose terms in different projects, Live, Horizon, previously Horizon, so all these FP project, but always losing the ground or losing the connection to the actual companies. And then when we started to think how to engage the companies realistically, with most of those 65 members, we have some kind of a relation, meaning that whether we done some services for these companies, we use some products, and then it allows us to know those members or those companies much better, so we can propose and engage them, matchmake, like a really real-time matchmaking to their true needs. So if they need an R&D, they have some kind of a R&D process going on, we can involve them into the projects. If they need internationalization or they need to scope the new markets, we can partner with our partners from the cluster, like Finnish Water Forum, to make it happen. If we want to get the feedback from the water utilities, we have Finnish Water Utilities Association with us as well. So we can get this truly working, and then gradually we were building the membership. The membership is free of charge, so it's not, but it's invitation only in that sense.
Right.
And one of the requirements from our side, very small one, is actually that we would like to have an insider knowledge about your product. Possibly have it in our laboratory tested or installed somewhat. So that's how we started. Of course, now it's not possible that every member we will have all the products from all the members, but that's how we started. We were building the water lab and our online water quality monitoring capabilities, and that's how we ended up in really expanding it to the cluster size.
Yeah, openness, transparency, like
Yes.
really being like collaborative and testing whatever and comparing and transparency is something that we would like to have. Easier said than done.
Yeah.
Everybody can, of course, but let's do it.
Yeah.
I guess it's not that easy. Talk a bit more about the job that you are doing, all these tests, all this research in terms of the drinking water quality.
Yeah, in terms of the drinking water, in the water lab, there's a water loop, which is a distribution system simulator.
Mm-hmm.
So this is the scaled-down version of the real water network. So it includes every component the water network should have. So we have our own water intake at the Savilahti. This is the actual lake that is next to our premises. There's a 1 kilometer pipe which connects that. So we have a first stage pumping station. We pump to the laboratory. Then in the laboratory we have the main tank, when you could think it's actually divided into 3 compartments.
Mm-hmm.
And in these compartments we can store different types of water. For normal testing we use the Kuopion vessel or the local water utility water for this purpose, but we also can take the raw water. We have our own containerized water treatment plant with which we can produce any kind of the water if we need to. In a continuous mode, meaning that this is the capacity of this water treatment plant is approximately 1 cubic meters per hour, up to 3 cubic meters per hour. But then we go back to the water loop itself. So this is almost 1 kilometer of pipes interconnected into loops and branches. How you have in your regular city.
I mean, you really have a mini city, or all reproduced as real as it can get.
Yeah. Yes, exactly, and it's fully automated. Because we can induce different scenarios, which I would tell a little bit more later. But there's also a lot of sensors installed. In terms of the parameters measured, not the unique, but the total parameters, we are measuring close to 100 at the same time, some with the intervals from seconds to minutes. So it's like overkill of sensors installed in one place. For many reasons, I'd like to call the water lab and the water loop as like a data factory.
You are collecting tons or mega or how many gigabytes? I don't know, tons of data.
Yeah, you can imagine that there's quite a lot of data being collected, also states. So not only the sensor values, but the state of the pump, state of the actuators, and all this is very precisely recorded in our database. So we know exactly what is happening. It is actually a metadata, as they call it, the data that describes the data. That's important for us because if the companies that are innovating not on hardware, but on software solutions, if they are building AI applications, you need this training and validation data sets. We are responding directly to this need. So they can have organized, wrangled data. Wrangled meaning that it's really neat. You can already ingest it to any kind of algorithm and get some post-processing and all this what is being reported now in this Congress, when this forward-looking research based on the overkill of data. We are not yet ready in the production and operational environment for that amount of data, but we will. We will, because that's why we have NB-IoT, we have 5G, we will have a 6G. It's already our partners from Oulu, our technological partner is Nokia. We are preparing ourselves for 6G even. In our premises, inside laboratory and outside laboratory, we have our own private communication network, 5G millimeter wave. That's not the 5G you have now in your phone. We have actually this millimeter wave where you have to wear your tin hat
to
protect yourself from radiation.
Yeah, because that's super powerful.
And NB-IoT, which is for actually those sensors that sense not that much data, but they need you are aiming for battery life. And then we have the one, even we go as low as 450 megahertz, which is not available as a public. We have it as a private frequency, band 31. And again, this is all because we have a bespoke partnership with Nokia and Elisa, the Finnish telecommunication provider. But I go back to those scenarios that we can recreate. This is really interesting for
yes, please.
For the companies that have sensors like. But anyway, in very compact time frame, we can recreate any kind of a scenario that could happen, God forbid, to happen in the real network, including even a cross-contamination. Cross-contamination, this is the worst. Of course, there's also intentional attack on the water source, which we can do quite easily. But the cross-contamination is when the wastewater is mixed slowly with the potable water. That's the worst what could happen. These kind of events happened.
They have happened more often than we think.
Exactly.
Yes,
exactly.
you can just need to Google it.
But we can do everything. Yeah. We could simulate or recreate a scenario even by order. So the company which won't like to see what will happen, or there's a client asking for this kind of a scenario, what will happen in the real network when we are, let's say, restating the pipe, unsuccessful restatement of the pipe without the disinfection and cleaning. So there's some kind of mishap during the installations. What will happen? How the sensors will actually respond? Because in our laboratory, you know exactly what will happen. I mean, like when it's going to happen. You just watch how the sensors are responding. So it's very convincing for if you are in the development phase, but for the water utilities, it's convincing to see how those sensors will actually respond when the bad things will happen in their network. So that's really important for them to understand. And we can do really a lot around it.
You can reproduce pretty much any scenario that, I mean, any given water utility. What if? And those if can be a very long list of ifs.
Yeah.
And you are pretty much able to
and then we can have like a really short, in terms of the temporal resolution. It could be really short one, mid-term, and also a long-term, because the water loop operates 24/7 all year. So we don't stop it. It's just a normal internal network housed in our laboratory. We control even the temperature. We can go as low as to 5-6 Celsius degrees, or we can heat it up. We can modify the pressure. The water loop can sustain operation at 10 bars even, and with the bursts above this, well, short bursts. We have been doing water hammer tests as well. So we are inducing the surge pressure surges in the network. So we can think that we can recreate not only the chemical contaminations, microbiological contaminations, but we can also recreate the hydraulic contaminations. When we can create a two-phase flow, adding in a controllable. We have a special gas mixer, which accurately measures how much, and we can have a pulse or other. We can control the size of the bubbles, which can actually fool some of the sensors when the bubble will hang, and
how the sensor reacted or didn't.
Yeah, exactly. And then the manufacturer can see, okay, that's the response of the sensor that has problem with air or with some kind of not the contamination. This is not the contamination even. This is something wrong happening with our device. So you can collect that, and it's still connected to the sort of small water network. So it's not in your laboratory on the table, disconnected from the realities of the water network. So this is really a big advantage from our side.
It's as real as it can get. You mentioned that, of course, you are collecting a lot of data, and you just briefly mentioned artificial intelligence. Are you creating your own AI? Or is that the scope, better said?
Of course, we are a university. In our university, we have the ICT department. As this is something that I am trying to. We are building the data repository. It's open for everyone to cooperate with us. We are very happy for non-commercial use to give it out to any research team if they would like to get the challenge. We actually give it out to a couple of our partners as a kind of a challenge. setting the okay, this is the data, because what everyone is on about is to take the existing sensors and build the awareness system. I know that early warning or this kind of
Early warning system, yeah, that's pretty
this is a known that there are many companies trying to get it done, but can we actually tell in a natural language what happened, or is it only like a fault, non-fault state in the network? I believe that we can interpret by having enough information, we can interpret what actually is happening and explain it to the operator, which is not an expert. It's just, it might be an expert, but we want that it is autonomous. It just thinks, interprets, and say, okay, this pH sensor is drifting. This is not a fault. Just clean the sensor. Okay, this is it needs a maintenance. Oh, hey, this is actually your booster disinfection going crazy. You are boosting it too much. So, there's some malfunction, or something other is happening in the network. That's where we are heading with the use of AI. And I was mentioning this open data repositories. I believe in smart water in a way that we have to give this data, keep this data open and available for even for the companies to build a new innovations on top of it. And that's what we want to do. We are also talking with the companies, startups from Kuopio about using the blockchain for data transactions, because you can think that data has some value, so you can think that it is also a product which you can at least have an ownership, because the transaction could be also on €0, but it is still a transaction when there is some value, and it could be a barter, like a.
But that's the value by using blockchain, that you can, of course, transmit huge volumes of data, like of encrypted.
It's more about securing the ownership and the integrity of the data. We are experimenting with the private blockchain. This is not you are not talking about Bitcoin here.
No. Yeah, I know, non-NFTs. No, yeah, that's, yeah.
But the concept is very close to NFT. When you want to have a kind of ownership of the data, in a way it is that. But for us, it's also about not allow integrity, not allow for any changes to the data for this or other purposes.
Yes.
So we experiment. This is very early for us. In our laboratory, we are experimenting with extended reality, and specifically with augmented reality. So we do many things which are not yet adopted by the water utilities, and everyone knows that water utility is sort of conservative in the adoption, and now is a big push because of the recent what we see around into even increasingly digitalization. But with increased digitalization, there is a risk for like a cybersecurity risk as well. And this is our topic, which we are cooperating with VTT, the Finnish Research Institute, and Nokia as well, because they are also providing the muscles and the integrity on the data processing, which might become an issue.
This gets super interesting. Of course, the possibilities that you may have with blockchain, and of course having a unique identifier and non-changeable like NFT, not commercial, yes, but all this sounds really promising. But when you come down in front of the water utility, the network manager, of course, dropping those words is like, what? So I guess we have to, talking the same language quite literally. The whole topic about digitalization. We have seen that, it's maybe the way the things have been working for many years, and they do work. And that's it, we just carry on. But what you have seen in that aspect, or who can be, what it can be the main thing to get them to accept at least, or to open, well, look, there's this thing called technology and digitalization that can help, that can make your job easier.
Yeah, I'm not here to judge, but I think that for the water utilities, they have to follow the rules. They have to follow the regulations, and then that's what they're supposed to do. They are not the critical infrastructure sector. It's not about the risk taking. It's they have to keep the integrity of the operations, and that's why they are very wary about making an abrupt changes to what was working 10 or 15 or 20 years ago. So this change is very gradual. And in many cases, you don't have a possibility to run the system on a site, see how it works, and then make it operational. For digital part, it is possible. So in that sense, you can have a parallel systems, then you kill the legacy one, and then you keep you kick off the new one. So in that sense, it's possible. But at the end of the road, there is always a timely delivery of the water to the consumers, and then of course the collection of the waste at the end. So then that's the main point, water utility. But the water utilities have the commitment for savings. The wastewater treatment is using notoriously large amounts of energy, so they have their footprint. They have which carbon footprint. For carbon footprint, they have to reduce. They have a water footprint which they want to reduce. Of course, we will have to pay for it, because when we start saving the water, there's still this operational cost, so the tariffs will go up. But that's the price we have to pay, and this digitalization allows to actually reduce the bill for the water utilities. So they are not going to need more manpower or womanpower to go forward, and so keep the costs also at the reasonable level. So digitalization is also about automation, not replacing people, but making sure that
making
it's
it
much
more efficient.
Efficient, exactly. And we don't do this mundane, like watching the screens and waiting for the things to happen. So that's there is, I think, one of the ambitious plans is that 100% of the events that happen in the water network, especially potable water, because it's connected with the health hazards for us customers, should be detected by sensors. Not, I think that currently it's like a 50-50. 50% is being early discovered by sensors at the end of pipe, at the end of the water treatment plant. And the other 50 is actually when there is already a consumer complaint.
Or physical sampling that they go
physical sampling
take to the lab.
With some delay. So then it's, we would like to be fully aware what is the quality of our water. But we should not forget about the stormwater and the wastewater. The climate change is bringing a lot of issues or a lot of challenges for us in the future. In Finland, it is forecasted that this number of this occurrence of the torrential rains, short bursts of large volumes.
Volume, and then they overflow. Quite literally,
exactly.
They go over the normal
like
capacity
flash floods. Yes. When in the past it was not occurring, so the infrastructure is not ready for it. So you need some kind of a real-time control approaches before you start digging out the pipes and remodeling everything to adapt. We are in this transition phase, and the underground modernizations or any changes to underground infrastructure is like super costly. It's really super costly. So it's not. You have to be very reasonable in your.
Yeah, of course. We have talked about wastewater monitoring, drinking water monitoring. Now you mentioned the third, storm water, which is, well, what I'm understanding is basically the flow or the volume. Yeah. So are you also doing this type of tests in your lab, or how?
Stormwater is because of course, this is the stormwater is triggered by the rain, obviously, and the ground flow and all that. So we in our laboratory, it's not the place for it. But super DMA, I didn't mention that. We were still in the water lab in the previous our talk. Now I can move outside, because then you ask for bigger scale. Because super DMA is actually the surroundings of the water lab, the premises of the water lab. Approximately is a designated area in Kuopio, about 1.5 kilometer by 1.5 kilometer, located around. This is like it's not strict because it's just designated by the location of these measurement chambers which we have on the water network. But as I was mentioning before, we are focused on all underground infrastructure, water, wastewater, and stormwater, and that's where we are building up. Not now. My main focus now is water, as we talk in the realities of time. But we are going forward also to make sure that we are going to build a response or similar opportunities companies have now on testing on the water or potable water on stormwater. The first steps would be, of course, to put sensors in the stormwater network.
Yeah,
And then from that take looking for new solutions in this area, but not completely in super DMA area. Savonia, as the university, I was involved in one of the projects in which we were developing biochar-based solutions to clean or pre-treat the stormwater before it's being discharged to the body of water. We set up a couple of pilots at challenging places, sort of hotspots. In Finland, it is especially this Lumenkattopaikka, meaning that's the place where cities are deploying the snow for being melted throughout the year, and these are leaching. Really, you can imagine when the snow is collected in the city, disposed in one place and start melting, it is actually leaking to the bodies of water.
Leaking to many places. Well, it's in some cities they just dump it to the sea. Like, whoa, is it good? Is it bad? And then again, every year is the same. But
now it's even in Helsinki. It's forbidden to dump the snow to the bay. So it's not possible anymore. And in Kuopio, we are making sure that we set up some kind of a barrier that is going to take all the harmful substances. In this case, it's heavy metal. We are targeting heavy metals, which are, we know what is happening because the snow is collected from the roads. So these are remnants of the rubber and the studs, this metal thingy that are on the wheels of the cars in those Nordic countries, the North countries, because of the conditions, and of course nutrients. So the nitrogen and phosphorus species. So we were targeting these. In these sites, also the Jättekukko, which is the local like a recycling center, but they have also like an industrial stormwater, which is washing off for all these elements that are stored in the open space, and then it drains to the stormwater. And one of the problems was also the concentration of oils there. We again tried to use
because
the biochar.
Like electrical appliances or home
Yes,
appliances.
exactly.
Like,
There's
of course,
like
they
a
have
wood
dishwashers
wood waste, metal waste, all the scraps that are being stored on the paved surfaces. And that's where then the rain comes and it washes everything, and then it drains to the local stormwater at this recycling center. So that was the issue. And the third one was actually placed in the city, where there was just from one of the catchment areas close to the city center, when we were also testing a regular composition of the stormwater, like you said, urban stormwater, because the previous two one were not so typical stormwater as you might see. Just to see how the biochar of different, of course, kind responds to it. We were cooperating with the cluster partner, University of Eastern Finland. They were coming up with the different ideas or the solutions actually for the biochar, and there were also companies involved. It was really interesting project.
And really big endeavor, like having, actually when you mentioned your, the ideal is that 100% of the events will be tracked and measured by sensors.
Exactly.
Is that, is the goal? Is that, when would you wish, I don't know if whenever it's possible, but wishfully, when would you like to have this?
As soon as possible for our own good. But
of course, but like realistically in the environment where we are, in the situation, like,
we need
are we
some
talking
breakthroughs.
years, decades?
I think that we need some breakthroughs. We need there's a technological gap which we are really looking forward to fill somewhat. Of course, there's this. If you want to have the sensor has to be cheap. It has to communicate easily. It has to have does not need the direct power like a plug.
Be autonomous.
And be autonomous,
Yeah.
possibly, I don't know, drain the
Energy
power. It's
autonomous.
possible to have like a small power generator, and it keeps itself like a zero energy. But for that, we need some breakthroughs in battery. In battery industry, we are still stuck sort of in
the lithium based
yes,
batteries.
Yeah, so that's I think one of the showstoppers. And much
Patryk's wish.
cheaper.
What is Patryk's wish? When this will happen?
Uh-huh.
5 years, 10 years, in our lifetime?
You want to have a realistic
yeah,
or over-promising?
Well, no.
I would
that's
be
wishful
over-promising, thinking that it will happen in the next 5 years. If we set up like a 10 years horizon for reaching 100% of events in water network being discovered or early discovered by the sensors, that would be reasonable to say. But on the way, we could have these breakthroughs, and that is going to be like a
Yeah,
jump.
you speed up, exactly.
Yeah.
Well, 10 years. 10 years seemed like a lot, seemed like very few, depending, of course, where you are, what's your perspective. And of course, from the consumer perspective, like, well, 10 years is like way, like, okay.
Yeah, but you notice the pattern. I just used like a 5 years, and then I doubled that for the unrealistic to, and then let's say sort of.
Okay, that's not okay.
realistic.
To minimize the comparison. But yeah, that's. But those 10 years, as you said, can be reduced politically if we foster this communication, this collaboration, and that's one of the key things I guess I'm getting for this whole conversation around here. And after talking to you, so transparency, collaboration, communication,
Exactly.
because we all are in the same industry, and there's no way that academia alone can solve it, manufacturers alone can solve it, or water utilities can solve it alone. So that's the message clear for all our industry to
Exactly.
collaborate and
Exactly.
This has been super insightful, Patryk. Thank you so much
Thank
for
you.
all your wisdom. No matter you told me, no, I'm not. Thank you very much. This has been super nice, and we will continue with more wisdom, with more knowledge sharing from the Urbanista. So keep tuning. Thank you very much.
Thank you. Thanks so much. Thank you for inviting me.
Thank you for listening to the Urbanista podcast, a production of Uponor Infra, the leader in sustainable infrastructure solutions. If you found it interesting, why don't you share it with your colleagues? We all together can move our industry forward.